Hello folks, I'm going to show you how to model a given data set using regressions uh, on a graphing calculator TI-8384. So it's a small data. It has only 5 points in there. So the first column represents the number of years after 1980. So I put the years in there. It's like 1, 3, 7, 10, and 24 for these years. So it's really simple, like 1981. It's just 1 because it's just 1 year after 1980. So Y being the number of cases for a certain disease. I mean, it can be it's not given in here, but we can just take all these numbers to and then we can use them. So it's 3, 12, 34, 44, and 48. So these are our Y values, these are our X values. The first thing that you need to do on your graphing calculator is just insert these values into the actual columns given in the calculator. So if I go into the stat button, this is what we're gonna be using mostly. So if I hit stat, you will first see edit, and if you click on enter, that will just allow you to enter these columns. So we're going to use the first two, first for the X values and the second one for the Y values. So I'm going to insert these values, 1, and then I insert 3, and then I insert 7, and then I put 10, and then I put 24. So these are all the X values in the first column. In the second column, I'm going to put my values for the Y. So it's going to be 3, enter, and then 12, and then enter, and then 34, enter, and then 44, enter, and then 48, enter. So this is what we get, and then we need to turn the stat plot on so that we can make the scatter plot. So we have to just see those points on the coordinate plane. So in order to do this, you see there just it says stat plot. We have to turn that function of the calculator on. So I'm going to do second and Y. That will take me to this plotting screen, and I'm going to hit the first one. I do the first one on, and then make this on. So I hit enter, and then I'm going to quit the screen. So then if I hit graph, you will see I only see like 1 point, not the other 4, and the reason is probably like default setting for the screen size is just -10 up to 10 for each coordinate axis. So you have to take this take the window size, like make it appropriate for your data set. So it starts by 3, goes up to 48, and the other one goes up to 24. So you have to make your minimum between, like for X, 0 up to maybe 30, and then Y from 0 up to 50. So let's make this. So let's make this 0, and then make X max to be 10, 30, and the next scale is 1, and then Y min 0, and then Y max 50. So when I hit this one and I say graph, you see now I see my data set, the points plotted on the coordinate plane. Now this looks like a logistic model, so we're going to be using logistic model. So logistic model is just simply at the beginning it increases really fast, but later on then it starts to increase slowly. Still it's an increasing function, but at the beginning it's increasing fast and it increases slowly. So it's kind of that type of data set that we have in here. So what you're going to do is so you will next continue to determine your modeling function. So it's going to be again down through stat. So I click on stat, and I'm going to do a calculation. So this is the list of regressions that you're going to use. So by looking at your scatter plot, like your data set on the coordinate plane, then you're going to simply choose one of these modeling functions in the list. So it can be, for example, if it's linear, you can use number 4. If it's quadratic, you can use number 5. Cubic, number 6. And for example, the other one that used a lot is logarithmic, ln, and then exponential regression, 0. Power regressions, but the one that we're going to use is logistic. So we have like a rapid grow and then slow grow. on our function, slope of increase. So if we click on this one, enter, it will just say logistic, and we want logistic, and when we hit enter, so we're gonna wait a little bit. It may take time. I mean, if you have something a little bit better, like maybe 84 plus or something higher than that, then this process might be something faster. So we're gonna be waiting for our function. So when it's done, I'm gonna simply write down the function in here. So it says your C, so that means the numerator in your function, the logistic function, needs to be 47. So it's 47 point rounded to 77. So that's the one, C. And then it says A is the coefficient of E, so I'm going to put that 16.49. And then the coefficient of B, it just says negative, so it just shows in here positive. It's going to be negative 0.53. So this is the function that simply models your data. So if you want to graph this on the same coordinate plane, you don't really need to write it down in this way. You can, the rounded one. So for example, I mean, just if you're using MyMATLAB, if you're using your MyMATLAB, probably the next question will simply just asking you to use the actual rounded function. But in here, if you want to graph it, there's an easy way to pull up this regression function. It's so easy. If you go to y equals, this is the list of functions that you want to graph. You're going to be working with y1. So you use the button here, it says wars. So if I click on wars, it's going to say number 5, we're working on statistics. And I enter, and then it says at the top, you can see equation. So you pull it to equation, and it says reg equation. So that will simply pull up your equation into the actual list of functions. So if I hit enter, you see your function is simply copied in here. So this is a beautiful option given in TI-83. And if you graph, you can easily see that your logistic function kind of not, I mean, it looks like that, but actually it's passing through really from the closest points to those data points. So this is how you do that regressions. If you want to, for example, let's say you want to figure out the number of cases estimated at, for example, I don't know, let's see, for example, let's say when X is simply, let's say 15, for example. Let's say this is your question. Now, the problem is this, you're going to be simply using this by using your function. You need to do this if you're working with MyMATLAB, or otherwise you can do this easily through the TI-83 value option. But I'm going to go to, like, I'm going to simply quit from this one, and I'll write this down. So it's going to be 47.77, and then this is divided by, I open the parentheses, and then it's 1 plus 16.49 times, I'm going to use E second ln e to the power negative 0.53 multiplied by, so I choose X to be 15, which is simple for 1995. So I hit 15, close the parentheses, and close it again, and hit enter. It's going to give me 47, roughly like 47.49. So which really makes sense. It's a value between 44 and 48. So it's going to be 47.49. I hope this will be helpful for regressions problems for you. I mean, again, the main point is first you graph your data set, and then according to its shape, you determine what modeling function or what regression function that you're going to use. Thanks for watching. Bye.